back, guys. Today we are back with another problem, and today's problem is converting a binary tree into a doubly linked list. Okay, so we will be writing our objective as usual. We are going to convert a binary tree, okay, and I'm going to convert it into a doubly linked list. Okay, so before starting this video, I would request you guys to go check out my other videos, my playlist. Make sure you guys like, share, and subscribe to the channel, and it helps me grow the channel as much as you are learning your interest in your DSM. So what you can see that we have a binary tree. We are going to convert this particular binary tree into a doubly linked list. Okay. Next, what is the information given? The left and the right pointers in the node will be used as the previous and next pointers. Okay. So what I can see in binary tree, a binary tree can be divided into a left subtree and a right children. Okay. So I can see left and a right. Similarly, this is representing, the left is representing the previous pointer of a doubly linked list. As you know, this is a data, this is next, okay, and this is previous in case of a doubly linked list. Okay, so what you can see that left is indicating a previous value and right will be also there. So right will be also indicating what value? Right will be indicating our next value. Okay, what other things it is saying. So the order of the nodes in the doubly linked list must be the same as the order of the given binary tree. The first node of in-order traversal must be the head node. Okay, so it is going to follow what type of traversal we are going to write. It is going to follow first node must be head. Okay, and the type of traversal it is going to follow is in order traversal. So if you guys don't know what in order traversal is basically nothing but the traversal which walks in this manner, left. Okay, the traversal which walks in this particular manner. It is going to go to the left, okay, and then it is going to the node, okay, and then it is going to come to the right. Okay, it is going to come to the right. Okay, so we are going to understand this with the help of some examples to make this even more clear. Okay, so let us first take an example of this particular binary tree. This is a 2, okay, this is a 3, and then this is a 1. Okay, so what is going to be the doubly linked list representation? The doubly linked list representation is going to look like this: 3, 2, and 1. So we are going to start from the left node, we are going to the root node, and then again we are going to the right node. Okay, now let us try to analyze the representation of another linked list. Okay, another binary tree. So we have a binary tree, say 3. Okay, 3 is subdivided into a 5, and then a 2. Okay, and then 2 is continued to a 1, and 1 is continued to a 4 and 6. So before starting explaining this problem, I would suggest you guys to know that this problem statement can also be termed as a flatten a binary tree problem. So it can be also given in your interview as how you are going to flatten a binary tree. So this is a very important question asked in all FANG companies. Okay, it is asked in all the FANG companies, okay, or MANG companies, whatever you guys say. Okay, you guys need to be thoroughly prepared with the concepts of binary trees. Okay, so we have this particular tree with us right now. So we have this 5, 3, 2, 1, 4, and 6. Now we are going to check. Okay, now we are going to check our head. Okay, so what we can check from our head is nothing but 5. Okay, we are going to start from here. So what you can see is we are going to move from 5 till the 3. Okay, and then 4, 1, and then 4, 1, 6, and 2. Okay, 5, 3, 4, 1, 6, 2. Now you will be saying, Arnav, how are you getting this particular traversal? Is this any technique? What type of algorithm you are using? So I will say I'm using a very simple algorithm. So I'll just write the algorithm over here. Of how to work with this particular binary tree. Okay, so initially I will be having a node previous value, which I will say as null. Okay, and I can also have node previous as null, and I can also say my since I can also say my head as null. Okay, these are my base initializations. Okay, after that what I'll be doing is I'm going to convert it, so I can say convert to doubly linked list. This is the name of the function, and I'm going to pass a node root over here. Okay, I'm going to pass a node root over here. Now what I'll be checking if my previous value is, so before checking my previous value I have to check the base cases, right? I just can't go directly to the previous values. So I have to check my base cases. So what are the base cases I can check? Everything starts with a root element. So I can write root is equals to null. So if my root is equals to null, then what I can do is I can return a null. I can return a null. Okay. And once my root is null, I can return a null. What will be my first step of in-order traversal? First is left, then root, and then right. So I've checked this. So I am going to go with the left. So I will write recursively call this function to move to the left side. So I will write root dot left over here. Okay. I'm taking this root. Now I'm going to the left side. Okay. After that, I'll be having an if condition. Now my previous value is equals to null. If previous is equals to null, what I will say, make my head as the root element. Make my head as the root element. So if this is my head, this becomes the root element. What is my root element now? 3. Okay, like that. So once this is done, what if my previous is not null? Means previous is not null, means previous has some values. In this case, you can see my previous is null. There is nothing over here. That's the reason I'm making the 5. That's the reason I'm making the 5 as my head initially. Okay. But what if it has moved over here? Means it is not null. So it is going to follow an if condition. So this was the if condition. So it is going to go to the else part, right? It is going to go and follow the else part. Else part says my root dot left is becoming the previous value now. Okay. And my previous dot right will become my root value. Okay. After that, the else block is complete. Till here is the else block. What if the if condition gets satisfied? What if it is a null value? What if it is a null value? Means our first condition gets satisfied, that we have no values over here to the left of this. Means our first condition is satisfied. Means this particular if condition is satisfied. This particular if condition is satisfied. Then it will not go to the else block, but it will directly jump over here and it will go to this particular line of code which says previous equals to root. Okay, it will make my previous value as the root value, and I will go and traverse to the right side. So I will again call the function, convert to doubly linked list, and I will say root dot right. Okay, so this was about the algorithm which we are going to write and which we are going to understand. Why I am practicing this writing on this whiteboard, so that you guys also can make notes of how this entire traversal works. This will help you guys understand how we can use the recursion stack, in order to make this problem more easier and approachable. Okay, so before any delays, let us go and solve the particular problem. So I'll just quickly reset my code. Now you can clearly see that we have been given a function node binary tree to doubly linked list. Okay, we have been given a function that which is node binary tree to doubly linked list. But remember that, let us read the question once again, because many of you guys have a habit of just going to the solution part and not understanding the particular lookout of the problem statement. So I will just clearly say, we will be given a binary tree. We have to convert it into a doubly linked list in place. Okay, the left and the right pointers, exactly, the left and the right pointers are in nodes which will be used as previous and next pointers. Okay, and which are going to be converted to doubly linked list. The order of the nodes must be the same as the order of the given binary tree. Okay. So we can see that this is our function. Okay, so we have to do the base cases, right? So we are going to write the base cases. If the root is equals to null, then what I can write, return null. Okay, if the root is equals to null, then I can return null. Okay, I'll make my head equals to null and my previous value equals to null. Okay, so I've made my head and previous value as null, and we know that we have to return the head of the linked list always in order to see that particular traversal. So but how we are going to return the head? So what we are going to basically do is we are going to make a util function. We are going to make a service function, right? So I can write void service. Service is going to give me the service of the backend of this particular binary tree, right? So in the service, I will be passing a node root. Okay, I'll be passing a node root, and I'll be implementing the exactly the same approach, exactly the same algorithm which I have written over here. First, if my root is equals to null, then I am going to return a null. Okay, so in my root, I will return if root equals to null. Okay, I'll just return. Why I'm giving a blank return? Many of you guys ask me this question because the function is of void type. Here the function is not void type. It is returning, it is of the type node. It is of the class node. That's why we can return a head. But here we can't return simply a head. So we are just going to return point blank. Okay. After that, we are going to call service. We are going to recursively call service function. We are going to go to the root dot left value. Okay. We are going to go to the root dot left value. Okay. Now, what is the next task I'm going to do? I'm going to do my previous is equals to null and head is equals to root. Okay. So I will check my previous is equals to null. Okay. If my previous is equals to null, what I will do? I will make my head equals to null. Okay. I'll make my head equals to null. So once that is done, what if my previous is not null? Previous has some values. Previous is now 1. It has 3 as values in this particular case. Don't get confused. So what we are going to do, we are going to follow root left becomes previous and right becomes the root. Okay. So you can say previous, I can say previous dot left equals to, I can say, I can just say root dot left equals to my previous, and this previous equals to root dot right. Okay, previous equals to, sorry, I just made a mistake. Previous dot right becomes my root. Okay. So as I told you that what if the if condition gets satisfied and it does not go to the else part, we have also a condition for that. We are going to follow the steps. Our previous value will become the root value. Okay, and we are going to call the recursively call the function again. Okay, so that we can go and traverse to the right subtree. So what I can write is root dot right. I can write root dot right. Just let me check. Yeah, I can write root dot right, and yeah, over here I have to call this service function, right? I have to call this service function. So I'll be calling service. Okay, I'll be calling service, and I can write root, and I can make this function as static. So we can call it. Let's compile. Cannot find symbol head equals to null. So in this case, what we can see as head is null in the error 158. Okay. So we have to initialize node previous and head. So we can write node previous. We can write node head. We have to again run through this function. Okay. We have to just write service. Let me just go through the code once. So we have a node previous, node head. We are taking a root element, checking the root as null. We are returning null. So head null, previous null. We are going to service the root, return the head. Okay. In the service, we are passing the root. If the root is null, then we will return. We are going to go to the root dot left. If previous is null, then we are going to make head equals to root. So we are going to make head as root, and we are going to compile this. So yeah, we are done with today's problem, and we'll be looking forward to solve more problems in the future. Thank you guys.